Problems on star to delta or delta to star conversion. First problem, find equivalent resistance between terminals A and B. That you have to find out what is the equivalent resistance between RAB. So between this and this, what is the equivalent resistance looking from this terminal you have to find out using star and delta transformation for the circuit shown in figure. So here that is depends on you how you are going to convert. So these two are in series. Okay. The 6 and 18 BR, because here nothing is there. No, you can consider these two are in series. You can reduce, you can write this as 20, 24 ohms. And here there is no only one resistance between this node and this node. There is only one resistance 18. And this is 6 and 6 and 6. All are same values and they forms Y form. That is star network. 6, 6, 6. They form 6 star network. You can convert the star to delta. Between these three nodes, you can consider only separate 6, 6, 6. Okay, and you can write equivalent delta for this. So that equivalent delta is this will be 6 plus 6 plus 6 into 6 divided by 6. So that is equal to, that is equivalent to, this is actually 6 plus 6. If you divide throughout by 6 now, you'll get 6 here. 6 plus 6 plus 6 into 6 divided by this 6. So this will be equal to 18 ohms. 18 ohms will get. So all resistance are same only. So that's why in all this you will get 18, here also 18, here also 18. So we can convert the star into delta, which is all are having 18 ohms. So you can replace with 18 ohms, 18 ohms, 18 ohms, 18 ohms, 18 ohms. So here actually earlier star was there 666. Now that is converted into delta of 18, 18, 18. After that these two are in series now, 18 plus 6, so that's 24. Now these two, between this node and this node, these two are in parallel, so equivalent is 10.28. And between this node and this node, these two are in parallel. So 18 parallel 18 is 9. If two equal resistance are in parallel, its value becomes off. So it is equal resistance, here it is 9, here it is 10.28 ohms. Now after that, this 9 ohms and 10.9, they are in series in this path. Whatever equivalent you will get here, whatever equivalent you will get here, these two are in series. So that if you add 10 plus 10.28 plus 10.9, you'll get 19.28, 10.28 plus 9. Now after that, actually we have to find out equivalent resistance between A and B. Between A and B, you have to find out. So we're looking from this terminal. Okay, here we have, this is independent 5, and here between you have a parallel combination of 18 and 19.28. So here this 13.8 is these two series. So after that we have to find out parallel combination of this as 19.28 into 18 divided by 19.28 plus 18, we'll get 9.3. After that we'll have this 5 ohm and equivalent of 9.3 between A and B. So if you look at from this, these two are in series. 5 plus 9.3. 5.93 is 14.93 is the answer. So it's an important problem. Let us do one more problem. Let us do this. Compute, which is also important problem. Compute resistance across the terminals A and B. Between this and this, what is the equivalent resistance? You have to find out using Y to delta, means star to delta transformation. So here you can observe very important point between this and this node. Between this is full, there is no element, so it is fully single node. This fully single node. Between this node and this node, we have three resistance, which is 54, 54, 54. No, three parallel resistance are there. So 1 over equivalent resistance between this node and this node is 1 over R equivalent is 1 over R1 plus 1 over R2 plus 1 over R2. All are same, no? So 1 by 54 plus 1 by 54 plus 1 by 54. If you take, it will be equal to divide by 3. Okay, it is 54 by, it is 3 by 54. So R is 54 by 3. If you take reciprocal, no? R is equal to 54 by 3, which is 18. So you're going to get 18 ohms. Instead of these three resistance parallel, I can write single resistance which is 18. So here it is written 3. Instead of 3, we have written 1 single 18. Now we have outer delta. What is delta here? 6, this 6, this 6, and here equivalent we written 1, 18 ohms. So those three you have to consider. I will write here 6, this 6, and 18. This is actually in the form of delta. So that you have to convert it into, because in order to simplify, again you have to convert this, because I cannot take this parallel with these two. So you have to convert this one to this delta to star. So you have to think properly. If I apply, that is good or not. So without transforming delta to star, it is a little bit difficult to convert. So better is you have to convert 6618 into star network. So for that one, this here you have 6, here you have 18. R3 value is, if I want to write in between this, it is a product of adjacent. 6 into 18 divided by sum of all. 6 plus 6 plus 18. 6 into 6. For this one is adjacent is 6 and 6 divided by sum of all. R2 is 6 into 18 divided by all. R3 is also 6 into 18 divided by all. So you will get 1.8, 3.6, 3.6. Now between those two points, we have 6 and 18. No? So we get these values. Between these three nodes, we are converting between these three nodes. Actually, what are there? 6, 6, 18 was there. That is converted into Y network of 1.2, 3.6, 3.6. Now these two are in series. Again, between this node and this node, these two are in series. 18 and 3.6 is series. And I have to find out what is the equivalent resistance looking from A and B. Now I can add this and this. 6 plus 1.2 is 7.2. Then 18 plus 3.6. 18 plus 3.6. 18 plus 3.6 is 21.6. Now again I am looking from these two terminals. These two are in parallel. That will get one equivalent resistance here. That is in series with 3.6. That is the answer. So parallel resistance of 2.6, 21.6 and 7.2. That is 21.6 into 7.2 divided by 21.6 plus 7.2. That will give you 5.4 ohms. Okay. And finally, last equivalent resistance will be, this is 3.6 ohms. This is 5.4 ohms. And looking from this terminal, these two are in series. So 5.4 plus 3.6 is 9 ohms. This is also very, very important problem. Coming to the third, okay, three impedances are connected in star. Find the equivalent resistance. You have to find single equivalent resistance. Or no, three impedances are connected in star. Find the star equivalent. Between three nodes, we have delta type. That is, uh, you have to find star equivalent. Three impedances are connected in delta, not star. It is delta, I think. You have to find star equivalent for this. These two are in parallel. These two are in parallel. So 7 and 7, 14 and 14 equivalent is 7, and 12, 12 equivalent is 6. Okay. This is 6, 12 parallel, 12 parallel 12 is 6, 14 parallel 14 is 7. Now we have delta connected network. So three impedances are connected in delta. No, that impedance are 13, 6 and 7. So you have to find out what is a star equivalent. R1, R2, R3 value you have to find out. So I already told, if it is in delta, if I want to find delta to star, it is a product of adjacent divided by sum of all. So it is 13 into 7 divided by 13 plus 6 plus 7. Okay. These are the star delta network. So product of adjacent divided by sum of all. So we are going to get 3.5. And this side 13 into 6, 13 into 6 divided by all. And this one R3 adjacent is 6 into 7 divided by all. So 3 ohms, and so only this much is the answer. You can write final answer as, you can write between these three nodes. You can write, you have to write last answer as this. R1 is 3 ohm, R2 is 3.5, and R3 is 1.615 ohms between these three nodes. Between these three nodes, find the star, reduced star equivalent is only these three. Okay, similarly, so many problems are given in the notes. You can follow, and sometimes they will ask this problem. This is also one of the important problem. Okay, let me do this. So you have to rewrite this diagram properly. So consider this is x, this is x, this is y. Okay, or I think this is a b c d, because this is c d, no. So let me consider as, oh, they are given x and y, no. So let me, this is be x only, this is y, and we'll call these two names as cd. Cd means this is you have to convert, this is 20, 20 is, this 20 is connected to the d, so this will be d, this will be c. Okay, we are rewriting the diagram into this form. After that, we have, this is one delta, this is another delta, so you can convert left side delta as that, while this R2 value is product of adjacent 20 into 45 divided by all, this R1 value is 20 into 10 divided by all, R3 is 10 into 45 divided by this all. So if you calculate, you will get R1 this much, R3 this much, and R2 this much. So we converted these 3 points, converted these three delta into star, whose equivalent value is 2.66 here, 12 here, 6 here. Now these two are in series, these two are in series. If I add 12 and 20, you'll get 32. If I add 6 and 20, you'll get 26. I want to find equivalent distance between x and y. Here only one resistance, but here a parallel combination is there. So these two are in parallel. So 32 parallel 26. 32 parallel 26 is 32 into 26 divided by 32 plus 26 will give 30. And instead of this, I can write parallel equivalent as 14.3. So 2.6 is in parallel, in series with, this is in series. This is in series with 14.34. If I add 2.6 and 14.6, the answer is 17 ohm. So the last answer is, it is 17 ohm. Between x and y, we have 17 ohms. And very, very important problem. You can go through this. If you are reading, we can go through this. It is also converted star to delta, delta to star, then finally simplify. Get one simple circuit, find the current. Once you find the current, power delivered by that is V into I. It's not so important. Okay, this is also one of the important problem. Let us do this. Using Y to delta, that is star to delta transformation, find current I. You would find what is the current delivered by this I. So here we have delta, this side also we have delta. So you can convert it into star. This value is product of adjacent divided by all. Again, R1 is product of adjacent divided by all. R3 is product of this adjacent divided by all. So R1 you are going to get 0.923. R2 you get 0.769. R3 is, you are going to get 2.36. So after that we converted between these three nodes, instead of 265, that is just delta network, we converted into star as R1, R2, R3. So we have written these between same three nodes, we converted into star network. Now these two are in series, these two are in series. If I add series 3 plus 0.76 is 3.769. 4 plus 2.3 is 6.303. Now next, these two are in parallel. 3.7 parallel with 6.03. We will get this much. And its value, if you write here, now these two are in series. So 2.93 plus 2.35 is 5.26. Okay, these two you have to add. 2.9 plus 2.35 is 5.29. Now I have to find what is the I value. I is voltage divided by this. So 50 volts divided by 5.23 is 9.465 amps. And this is also an important problem. Find equivalent resistance between A and B. So these two are in, see, this point is here. Don't think that, it is not here. It is at here. And this is at this point, not this side. So while taking these two are in series, simply in order to confuse, they'll give like this. Instead of writing 6, they split it. So these two are in series and these two are in series. So we'll get 15, 15, this side 15, 15, 15, 15 as one delta, and 6, 6, 6, 6, 6, 6 as another delta. So you have to transform this. So here, if you want to convert delta to star, this value is a product of adjacent divided by sum of 6 into 6 divided by 6 plus 6 plus 6 is 2. Same value for all, because all are same values. So we'll get the same answer. Similarly, right side, 15 into 15 divided by 15 plus 15 plus 15, which will give you 5 ohms. So after that, it is easy. We converted into one star network, this one, and another star network as this one. Now, in order to further simplify, we have to find out equivalent distance between A and B. These all are in series, 2 plus 41 plus 5. That is in series with these three. These are also in series. 2 plus 7, 17 plus 5 is also in series. So 2 plus 17 plus 5 is 2 plus 17 is 19 plus 5 is 24. 2, 41 and 5 are also in series. This is 48. Now this 48 and this are in series parallel. 48 and 24 are in series. This we have written as it is 5 ohms. This 2 ohms we have written as it is. Only this center part we are reducing into single resistance. This is a parallel. Sorry, this is series. Get one equivalent resistance of 48. Below path is also series 24, and now 48 and 24 are in parallel. So do 48 into 24 divided by 48 plus 24, you will get 16 ohms. So once you write 16 ohms, now all are in series. 16 plus 2, 18, 18 plus 5 is 23. So this is also very, very most important problem. So you can consider this as a most important problem. This is also same type, no change. This is also same problem. Okay, thank you.